Now, numerical problems regarding convex mirror. Previous three problems regarding the concave mirror. Keep in mind, concave mirror also called as converging mirror, because all the reflected rays are converged at the point. So converging mirror. Concave mirror is also called as a converging mirror. Convex mirror is called as diverging mirror. Sometimes in examination at the question paper and the problem, they didn't mention concave mirror and the convex mirror. They said that if the object placed in front of converging mirror at a distance of something, so converging mirror is concave mirror, diverging mirror is convex mirror. So these two are keep in mind. So let us do the problem. An object 5 cm high is placed at a distance of 10 cm from a convex mirror of radius of curvature of 30 centimeters. Find the nature, position and size of the image. Right? So let us find. Read the problem again. An object 5 cm high is placed at a distance of 10 cm from a convex mirror of radius of curvature of 30 cm. Find the nature, position and size of the image. So convex mirror and concave mirror and whatever, mirror formula is 1 by f equal to 1 by p plus 1 by u. Magnification this one doesn't change the form. So what are the values are given first? Right? Given values, height or size of an object. How much? 5 centimeters. Then distance, object distance u equal to 10 centimeters. So convex mirror kind of concave mirror kind of object distance is negative. Then what is given next? Radius of curvature r equal to 30 centimeters. Radius of curvature r is equal to 30 centimeters. Keep in mind, for convex mirror, object distance only minus. The remaining image distance, focal length, radius of curvature, all are the positive only. Because so in case of a convex mirror, this is the pole, object is placed this side. So this is opposite to the direction of the light rays, kabatti minus. The remaining all are this side only. So here the focus, here the center of curvature. So focus or center of curvature. So here to here object distance. So negative. So these are remaining all focus, focal length, center of curvature are along the direction of light rays. So all should be taken as a positive. So object distance is positive. Size and height of the object is positive because of it is above the principal axis. And we know, in case of convex mirror, the object placed at any point in between focus, in between pole and the infinity, the object is always forms the virtual images that too forms where in between focus and the center of curvature. focus or center of curvature that is formed always above the principal axis. So it is always positive. Only the object distance is negative. Only the object distance is negative. The remaining all are the positive. Next, what we have to find? Find the nature, position and size of the image. Find the nature, position and size of the image. So, nature of the image is always we know virtual image. So, nature of the image. Nature of the image is virtual because we know convex mirror always forms virtual images. Keep in mind where the position of the object is. Convex mirrors always forms the virtual images only. So diminished or size of the object is less than the size of the object. Size of the image is less than the size of the object. So nature of the image of convex mirror. Nature of the image formed by a convex mirror is always virtual and diminished wherever the position of the object is. But in case of the concave mirror, if the object placed between the pole and the focus only forms virtual image, then the remaining position forms real and inverted images. Then, to know the position of image. To know the position of image means at which distance the image is formed. Which formula we have to use? 1 by f equal to 1 by v plus 1 by u or this one also. But we don't know the size of the image. We don't know the size of the image because of magnification of the image didn't give. Magnification of the image didn't give. Or doesn't give does not give the image distance also. So now know the position of the image. To know the position of the image, what is the formula? 1 by f equal 1 by v plus 1 by u. But is there any focal length? No. So but given clue, one is radius of curvature. Radius of curvature. Radius of curvature is double to its focal length. Radius of curvature is double to focal length. So, radius of curvature r is equal to 30 centimeters. As we know, r is equal to 2f. R is equal to 2f. R equal to 2f. From this, f equal to r by 2. From this, f equal to r by 2. From this, f equal to r by 2. So substitute r value is 30. 30 by 2, that is equal to 50 centimeters. So focal length is 50 centimeters. Now we know focal length object distance by using mirror formula. Then we are able to find the nature of or size of position of the. From the formula f equal to 1 by v plus 1 by u. From this I have to write 1 by v is equal to 1 by f minus 1 by u. 1 by f minus 1 by u. So substitute the values, that is equal to f value 50, 1 by 15 minus of object distance 10, 1 by minus 10. So minus cancel. So 1 by 15 plus 1 by 10. 1 by v is equal to 1 by 15 plus 1 by 10. So 1 by v is equal to LCM 30. 52 jar 2 plus 10 3. That is equal to 5 by 30. 1 by v is equal to 5 by 30. That is equal to 1 by 6. 5 1 5 6. So 1 by v equal to 1 by 6. So from this we have write what is v is equal to 6 centimeters. V is equal to 6 6 centimeters. So V is equal to plus 6 centimeters. What is the position of the object? The position is formed at 6 centimeters of the image behind the mirror. 6 centimeters. 6 centimeters means the image is formed at 6 centimeters behind the mirror. Behind the mirror. So now we know object distance, image distance. Then easy to calculate the size of the image. Size of the image. Size of the image nothing but magnification. Where it is formed. So let us calculate where the image is formed. So from this magnification m is equal to minus p by u formula we have this. Or height whichever one, no problem. Height is given. So before what you have to find again? Magnification. Magnification find. So keep in mind u is equal to minus 10 centimeters. V is equal to plus 6 centimeters. From this find the magnification here. M is equal to minus V by U. So minus of 6 by minus 10. So minus cancel out, then M is equal to 6 by 10. M is equal to 6 by 10. 6 by 10 and we have write M is equal to minus 0.6 minus 0.6. M is there. Height of the object also given. Height of the object is equal to 5 centimeters. Magnification is there. Height of the object is there. Then find the size. So magnification M is equal to HI by HO. From this multiply HI is equal to M into height of the object. That is equal to M 0.6 height 5. That is equal to 3.0. HI is equal to 3.0 centimeters. So 3 centimeters. So size of the object is 3 centimeters. So what is the nature? Virtual and diminution. Position of the image. V is equal to plus 6 centimeters from behind the mirror. Find behind the mirror. What is the size of the image? Size of the image HI or H2 equal to 3 centimeters. Nature is virtual diminution. Image or position of the image plus 6 centimeters behind the mirror. Size of the image is 3 centimeters. Diminution and the size small size. What is the object size? 5 centimeters. What is the image size? 3 centimeters. Size decrease. So diminution image. So in this way we have to calculate some values regarding to convex mirror. In case of a convex mirror, object distance whole is negative, remaining all are the positive. Keep in mind because object is placed in front of the mirror, object is opposite to the direction of light rays. So then the focal length, radius of curvature, height of the image is positive. Height of the object is also positive because of these two are above the principal axis. According to sign convention rule, above the principal axis taken as positive. below the principal axis taken as negative. So this is one problem regarding to convex mirror. Then try to solve the one more problem. Practice the problems. Practice the problems. So formulas, mirror formula, magnification formula, sign convention rules. Sign convention rules are important. Later I will give some example problems. So please try to solve them. At least try if you understood. If you understood, try to solve the problem. Try to solve the problem and give a comment. So views are okay, 1 or 2 whatever. So please give a comment. You understood or not? Right? Subscribe the channel. Share with your friends. Share with your friends. Don't forget it. Then one more problem you have to try. Let us discuss one problem. An object is placed. An object is placed. An object is placed 15 centimeter. 15 centimeter from a diverging mirror, of radius of curvature, 20 centimeter. Radius of curvature 20 centimeter. Calculate the image position. Calculate the image. Calculate the image position. Calculate the image position and magnification. Magnification and position of the image should be found in this problem. So see the problem again. An object is placed 15 centimeter from a diverging mirror. So which one is called the diverging mirror? You know, is convex mirror. Convex mirror is called as the diverging mirror. Whereas the concave mirror is called as a concave mirror. The converging mirror is concave. Diverging mirror is convex. So, see. Solution. An object is placed 15 centimeter from a diverging mirror. So, object distance is equal to minus 15 centimeters. For the diverging mirror, for the converging mirror, object distance is negative only. Always it is the negative. Then one more, radius of curvature. R equal to 20 centimeters. This is positive value. What you have to find? Position of image. To know the position of the image, you have to use the formula magnification. Formula 1 by f equal 1 by v plus 1 by u. So focal length f equal to r by 2. F equal to r by 2. Substitute the values. 20 by 2, that is equal to 10 centimeters. So focal length f equal to 10 centimeters. To find the position of the image, we require either the magnification undali, ledante height of the image, height of the object undali. So didn't give this problem. Only the object distance is given. If the object distance only is given, and use this formula. So radius of curvature is given. So from the radius of curvature, we find out focal length. We find out the focal length. So focal length we know, object distance we know. From this, find the position of the image. So 1 by f equal to 1 by v plus 1 by u. From this, 1 by v equal to 1 by f minus 1 by u. That is equal to 1 by 10 minus of 50 ఇది ప్లస్ అవుతుంది 1 by 10 plus 1 by 50 1 by 10 plus 1 by 50 so 1 by f equal to as usual గా 30 వస్తుంది కదా రైట్ ఎస్ఏ చేస్తే 10 3 jars 2 so 1 by f equal to 5 by 30 that is equal to 1 by 6 1 by f equal to 1 by 6 so sorry 1 by v so 1 by v is equal to 1 by 6 and then v is equal to 6 centimeters so similar problem is the same right right similar problem same object distance for image distance or position of the image is found at 6 centimeters so then what we have to find out here magnification so magnification formula m is equal to magnification m is equal to minus v by u so minus object formed at 6 image at sorry image formed at 6 so object is 15 so 6 by 50 6 by 50 so how much we get plus 0.4 so if the simplification cheste magnification vastundi so 3 2 are 3 5 are 2 by 5 that is equal to 0.4 m is equal to 0.4 is equal to 0.4 plus also convex mirror so m is equal to plus 0.4 so position kanunna ekkada position of the image is 6 centimeter plus 6 centimeters from the mirror and also formed behind the mirror and also formed behind the mirror and also formed behind the mirror so in this way we have to calculate solve the numerical problem numerical problems are very easy when we know the sign convention rules because should be mentioned correctly for plus or minus depending upon the position of the object so depending upon the position of the image sign convention rules are very important size of the object size of the image if the image and the object above the principal axis is positive if it is downward it is a negative object distance for the concave mirror or the convex mirror is always negative right then image distance for the concave mirror is negative Image distance for the concave mirror for convex mirror is positive. Focal length is negative for concave mirror. Focal length is positive for convex mirror. So in this way, keep in mind. Yesterday I gave tabular form also. So the tabular form, understand the tabular form, understand the sign convention rules, and know the position of the object, know the position of the image. When we know the position of the object, position of the image, then we have to know the nature of the image. Real inverted image, virtual image, diminished image, enlarged image. So these are the important. Simply the final conclusion, the final tip for solving the problems are: know the position of the object in front of concave mirror or the convex mirror. In case of concave mirror, if the object placed between the pole and the focus, in case of concave mirror, in case of concave mirror, object between pole and focus forms virtual image, enlarged image. So then in the remaining position, where center of curvature and focus, అయితే ఎక్కడ ఇమేజ్ ఫామ్ అవుతుంది? ఇన్ఫినిటీ, రియల్ అండ్ ఇన్వర్టెడ్. ఇఫ్ అట్ సి అయితే అట్ సిలోనే ఫామ్ అవుతుంది. సో రియల్ అండ్ ఇన్వర్టెడ్ సేమ్ సైజ్. ఇఫ్ అట్ ఎఫ్ అయితే అట్ ఫోకస్ అంటే ఏమవుతుంది? at F, if we place the object at focus, where the image is formed, infinity, between center of curvature and the focus, and behind the seat, behind the center of curvature, enlarged image, real and inverted. At F at focus ante at infinity form, at infinity. So behind C aithe between C and F, ఇది position of the object and position of the image regarding to the concave mirror. Object distance negative, image distance also negative, focal length negative, radius of curvature negative, right? Because we are left side of the pole. Then regarding to convex mirror lo, where the object placed in between the pole and infinity. Regarding to convex mirror, between pole and infinity lo pette image formed virtual image form between focus and center of curvature. If at infinity aithe at focus. So virtual image, convex mirror always forms the virtual images. Right? Object distance is negative, image distance positive. focal length positive because of they are all the direction of light rays F C all are along the direction of light rays. Object placed here, this is opposite to the direction of light ray, so object is negative. Object distance is negative. Image distance is negative. Focal length is positive. All are positive. So object is above the principal axis. Image also above the principal axis. Kabatti size of the object, size of the image is positive. But in case of concave mirror, what will happen? Object size of the object or height of the object positive. Height of the object is positive, right? Height of the image is positive in case of virtual image form. Remaining all cases negative because it forms down to the principal axis. Object is always above the principal axis, so positive. Image is always negative down to the principal axis, so it is a negative, except virtual image form. And these are the formulas. Sign convention rules. All the distances measured from the pole. If anything is opposite to